All right, so we're going to do a circuit breakdown, a series parallel circuit breakdown, where I'm basically going to give you a complex circuit with some known values and some missing values. And what we're going to be looking to do is use our rules for series and parallel to identify what we have and what we can find. So here's a circuit I'm going to draw. I want you to copy down this circuit. We have a power supply. I'm going to call that Vs. Sometimes you see that as V total. That's given as 10 volts. We're going to leave that power supply, and we're going to go through a resistor, and we're going to hit a split. And I'll plug in the values here shortly. All right, we're at that split. We're going to go through another resistor, or we can go through this resistor. Now these pathways are going to come back around, and they're going to merge. And then we're going to go through another resistor here, and we're going to get back to our supply. So there's our circuit. I haven't put in any values yet. Now, some of the things we're going to know in this circuit. I'm going to label this R1, and I'm going to give it a value of 5 ohms. So that's given. I'm just going to put in all the given values. Let's call R2 this one. And let's say that that is 4 ohms. We'll call this guy R3. R3 will be 12 ohms. R4, we're going to leave as an unknown. All right, and then we got some other unknowns. We have V1 and I1, which we don't know. We have V2 and I2, which we don't know, and V3 and I3, which are also unknown. And V4 and I4 will be unknown as well. In order to solve this, I got to give you one more piece of information, and that's going to be the total current coming out of the battery. We'll call that I total, and that's going to be 1 amp in this circuit. The other piece you're going to want to find as a hint is Req. Req is unknown as well. All right, so we got all these blanks here. Notice the circuit itself has a supply, it has an equivalent resistance, and it has a total current coming out of that battery. And then each individual resistor has a resistance value, a voltage drop, we call those V1, V2, V3, V4, and a current that's passing through them. And what we're going to try to do is utilize the rules we know about parts of circuits that are in series and parts that are in parallel to break down and start filling in the gaps. And so it's kind of a puzzle. We're going to start to piece this together, and I'm going to put you guys in groups. I'm going to pause my video and let you guys start working together to figure this thing out. All right, so now you guys have had a chance to look over this. Let's look at some different possibilities for how to break this thing down. The first step really depends on you. Kind of like a puzzle, there's kind of interconnected pieces when you're evaluating this. To me, a couple things I notice right away are that since I have the current out of the battery, anything that's in series with that battery, meaning there's no choice, that would have the same current. So I might right away say that, well, I know I1 and I even know I4 as I'm passing through to be 1 amp. The other thing you might notice is, well, I have the supply voltage, the total current. I should be able to calculate the equivalent resistance because I have 2 out of those 3 things. Those are the 2 places that I might start. I'm going to start with that equivalent resistance. That's usually a good place to go because I think if I go the other way, I will hit a dead end, and you might have seen that as well. So my first step, doesn't matter which one you choose, either way, you'll kind of it'll lead you to the next thing. But I'm going to use the supply voltage and I total to calculate what the equivalent resistance must be. And again, we use Ohm's law to do that. And we know that Ohm's law says that V equals I total times the equivalent resistance. And so Req would have to be that supply voltage over the total current, which in this case, my supply voltage is 10 volts. My total current is 1 amp. And so my Req is 10 ohms. And so I can write that in here as 10 ohms. All right, so there's my equivalent resistance of my circuit. Now with that, we have all of the other resistor values and with the equivalent resistance. So theoretically, we can take that and figure out what R4 must be. So my next step right now is to figure out what is R4. All right, so we're going to use Req and the other resistors to find R4. Now that we have that, we have everything but one missing resistor. All right. So we're going to use Req and the other resistors to calculate R4. All right, and so in doing that, I'm going to do my circuit redraw to set up my equation for equivalent resistance. Now, if I'm drawing this circuit, all right, I'm going to be leaving the positive. I go through R1. R1 is 5. Then I hit that split, and I can go two ways. I can take my high road, and that's going to take me through the 12 ohm resistor. I think that we call that one R3. Or I can take the low road and go through R2, and that was a 4 ohm resistor. And they merge back together, and then I go through R4. So R4 is my unknown, and there's my redrawn circuit, which really gives me a sense of what's in series and what's in parallel. And as a result, right, I can calculate now that parallel combo of 12 and 4. Well, we learned our rules. It's got to be less than 4, right? So this right here is going to be 4 to the negative 1 plus 12 to the negative 1, and that whole thing to the negative 1. That ends up being 3 ohms. And 5 is in series with that, so 5 plus that parallel combo plus the unknown resistor has to equal my equivalent resistance, which is 10 ohms. And that means that R4 has to then be 2 ohms of resistance. All right, so we've basically figured out from the missing pieces that I know R4 is now 2 ohms. So I have all my resistors now, I have my total current. And now let's start looking at those series and parallel rules. So now that we know, again, we could have done this as a first step, but I'm going to use my series current rule. What happens when you have to pass through, series current rule, to fill in I1 and I4. All right, notice in this circuit, I really have 2 loops. I can pass through one way, or I can go through R1, go through R3, and come back through. Regardless, I have to pass through R1 and R4, and so I know that they see all of the current, 1 amp and 1 amp. All right, every car on that highway will go through those toll booths, so they will get all of the current. All right, and as a result, I know those 2 currents. It will split. Right, some of the current's going to split to R2, and some's going to be R3, but I at least know those 2, which means now I have 2 out of those 3 pieces. All right, so we're going to use Ohm's law to calculate the voltage drop across the resistor 1 and resistor 4. The voltage drop across 1 is got to be the current through 1 times the resistance of 1, which is 1 amp. And that first resistor was 5 ohms. And so I get a voltage drop of 5 volts through that first resistor. This has got to be 5 volts of drop. And same thing with V4, right? 1 times 2, well, 2 volts, right? Ohm's law fits for each resistor. And now we can look at those loops and figure out the remaining voltage drops. So since we know the voltage drops of 1 and 4, well, in that first loop, we're going to use our parallel loop rule. Use our parallel loop rule to determine the voltage drops across V2 and V3. So if we take our red loop, right, we have voltage across 1 plus the voltage across 2 plus the voltage across 4 has to equal our source voltage, right? That's one pathway. If you notice in red, I made a red loop that goes through 1, 2, and 4. Well, those then have to drop all 10 volts, and we know that you have 5 and 2, so right here we know this is 5 volts plus the unknown V2 plus the 2 volts has to equal the supply voltage. And so V2 would therefore have to be 3 volts. And so I know my voltage drop across V2 now, and I can plug that into my table. V2 has got to be 3 volts. And if you look here, 5 plus something plus 2 has to be 10. Well, aren't these in parallel? Don't parallel pathways have the same voltage drop? Well, then this is also 3 volts, right? And you see that that green loop would have 10 volts total of drop. And the last step is to figure out I2 and I3 using Ohm's law. All right, so we know V2 and V3 also is 3 volts, right? These are parallel pathways, right? Same voltage in parallel. And so my last step is to use Ohm's law to calculate I2 and I3. And so I2 better be equal to the voltage across 2 over the resistance of 2. We know the voltage across 2 is 3 volts. The resistance of that one is 4 ohms. And so I get 0.75 amps across I2. So when this 1 amp of current splits, most of it, 0.75 amps, goes here, which makes sense, right? There's less resistance of the flow. It's a faster toll booth, so more of that 1 amp will go through the 4 ohm. Now, we also know because that current splits one way and the other, they should add up to 1. So even right here, I should know I have the remaining 0.25 amps to go here. All right, and if I calculate I3, I would get V3 over R3, the same 3 volts, but now divided by 12 ohms, and I get the 0.25 amps. And notice if I add those up, they get the total current coming into that split, which all checks out. So now we've gone through this circuit. We've used a combination of our series and parallel rules. All right, every loop drops all the supply voltage, all 10 volts. And all that current, the total current when it splits proportionally between those resistances along those pathways. But then always merges back together to get to the battery. And so now we've effectively broken down this circuit, and everything checks out and matches up using those rules.